Good morning, everyone. I am Ravi Prativadi, Manager of Software Development from T-Mobile. Along with me, I have Linga, one of our principal engineers, and Ramesh, one of our senior engineers. We are part of the middleware stack in T-Mobile. Today, we are here to share our success story, give an overview of one of our critical applications in T-Mobile called Retail Services Platform. Just to give you an overview of what this application is. This application is one of the critical applications in T-Mobile, which has been served for all our internal customers and also the external vendors. And it is important for the journey of T-Mobile, like we need to actually migrate this application into, I'll explain what are the pain points that we have with this application and why we had to migrate this application to cloud. Just a quick overview. This application is built on a SOA-based architecture with Java and Spring framework and has more than 400 plus SOAP operations in the application. And it's running on WebLogic. And on an average, it takes around 60 to 70 million traffic per day. So it was one of the critical applications because all our internal applications, in-house applications and external vendors use this application to perform all key functionalities of T-Mobile. Being a monolithic application, it has its own share of pain points. First of all, being a monolithic itself is a big pain point because it is tough to manage and maintain a huge application like this. And the response times. There was a huge demand from our internal customers to improve the response times to meet the organization goal of 2 seconds. It's not like that our application was responding really bad, but there was always this demand from the team that we need to improve it further. Next, time to deliver. With a growing company like T-Mobile, there is always a competition from all our competitors, and to meet the business demands, it was always important for us to deliver things on a much quicker pace, which was a huge challenge for us when we were on this monolithic application. It used to take on average of 3 to 6 months to deliver any new functionality from the business initiation to production. Next is a scalability. For example, like we had this new device launched recently for iPhone. And also whenever we have these promotions, there is always a huge traffic and that's inflowing into our systems. So in order to sustain the traffic, our ops team has to spend 3 to 6 months in advance to bring up or scale up our application manually, which was a huge concern. And lastly, the application outage. For an application like Retail Service Platform, which is really huge, just to deploy and bring it up, it used to take 30 to 45 minutes in one instance. And to sync it up in all the instances, it used to take an average of 4 hours, which was a huge concern because we cannot push any changes into production during the daytime. It always has to be in the night, so we had to spend all night deploying our changes and making sure it's working fine and not impacting everyone. So we'll have an overview of what our monolithic application looks like, followed by our cloud platform. To start with, I'll hand over to Ramesh to give an overview of our monolithic architecture.
Thanks, Ravi. Good morning, all. This is Ramesh from T-Mobile. So this is how our legacy monolithic RSP application architecture looks like. So we get calls from our retail channels, care channels, self-care channel, IVR, business channels, and partners such as Amazon and Apple. All the calls that we get comes through a gateway that is called API Exchange for us. So the technology that we use in RSP application, we use Java and Spring framework for the development, Oracle WebLogic Server for the deployment, Oracle as a database, Wiley for the monitoring, Apache Ant for the builds. We use access and text templates for the generation of the web services. And RSP application will interact with more than 40 backend systems, which has various types of connections such as Jolt, web services. We had file-based processing, we had JMS processing, we had J&A lookups for the data sources, right? And RSP application follows our principles, service layer platform. It has more than like a 40% abstraction to the system of records. We had a logging framework. It can be manually scalable, which has a single code base, and which is like a 1 AR deployment. So this architecture is really worked well for us, as some of the process in this is automated, like the generation of the visual is automated, generation of the service implementation, DO implementation of the skeletons is automated. So the governance is very easy for us to do this, because some of the procedure monitor, any new developer comes in. So you just need to follow the whatever the guidelines that we have. But as we started seeing a problems managing this application, as the T-Mobile customer growth has increased every single day, and the volume that receive is increased every single day. So before we begin with the Cloud Foundry, I will take an use case of our one of the service, how it behaves, and what is the pain point that we have, and what are the challenges that we ran into when we scale the application. So this is a customer info, one of the app service, which takes around 12 million calls per day, especially during new product launches or any promotions. The volume will get doubled up very easily. To scale this up, so earlier in 2014 or 15, earlier 2015, what we had is very less promotion. That is like we had a promotions only during new phone product launches such as iPhone or Samsung. That time our ASM is, we know when Apple is launching or when Samsung is launching, we used to already prepare before 6 to 7 months, from the procurement to installment and deploying the app and get ready. But as trend grows on, like T-Mobile growth is getting increased every day, and everyone started using mobile much more, and it drives us much more volume, and our business interest is so rapid, and we have some of the other promotion every week or month. So we don't know when to scale, how much to scale, right? That's one of the major pain point that we had. And other pain point that we had is the challenge that we had is faster delivery. So RSP, an application which is 500 MB of EAR. So to build, it takes around 30 minutes. To deploy, run it in local, which takes around 2 hours. While I was in offshore, I used to go for a coffee break. Coffee break is for 1 hour long. Okay. Then I comes back, probably the time my server comes up, and I will do a code test. Even for a single change, if I put just an if condition or just a logger statement, if I have to test in local, it takes around 3 hours of time. So, and also in terms of the scaling, right, during the product launches, only particular service will get more calls, like a customer info or handset service, which is basically handset based ones. So to scale that, we need to scale the entire application. That requires more memory and infrastructure. So other challenge is outage, right? Whenever we have any change, right, to drop the change in QA, let's say I developed some code and I deployed in QA for the testing environment. If they found some defect, to fix that issue, even though it's a small or big, it takes around 1.5 day to 2 to get into QA cycle. That means every defect that comes in QA cycle, which takes around 2 to 3 days to resolve and test it effectively. And at the same time, when we go to the production, and also this requires like 2 to 3 hours outage of in QA environment, so that's like we are shortening our QA testing cycle. So we had onshore and offshore, which works on 24/7, but during these outages, they have nothing to do. So and also on the production deployment, we can do only during deployment dates, specific deployment dates. Earlier, T-Mobile has only certain major releases. I mean, in a year, we used to have like 3-4 major releases and 10 to 11, 12 minor releases. So whenever we have to make any change, we have to deploy in a particular window. If we miss that, we have to deploy in the next window. That means if business requirement is to deliver in October, if we can't, if they give us a requirement in September, we won't be able to deliver in October. That means we have to deliver it only in the December or January, which has the next major release. We can't push in between. That's one of our challenge for delivering the faster code to the production. So, and with the rapid growth of the volume, we had an issues with the JMS. We are using WebLogic JMS for the messaging system, which is tightly coupled with our application layer. Whenever we had some challenge with JMS, that impacts our real-time calls, which introduce latency. Yeah, and one of the other major challenge that we had is the rollback. During NODs, we deploy the code, we validate it, everything looks fine. But during business hours, we found some functional issue. To roll back that particular new code, which takes around, during business hours, we can't take an outage, so we used to do a rolling bounce, which typically takes around 6 to 8 hours, which is a bad customer experience to our front-end apps and to the customers. Even the logging is the same case. So we have a very good framework for the logging, where we can log entire request from the incoming request to all the backend calls, everything we can log it. So that really worked well for us, but with the growth, pushing to a JMS queue or EMS queue is become a bottleneck. Whenever we had challenge to push the message to the queues, the backpressure will come to the application layer, and we started latency in our applications. So this entire RSP application is single code base. So if you touch a single line of the code, we need to rebuild the entire EAR, and we need to do an entire regression of the test suite, which takes a lot of time for us. So build and deployment is again, so we use an AND for the build and deployment. So whenever we any build, we do a jar and we upload to Artifactory and we hand over to ASM. That's a manual process we need to do. There are chances that our ASM could deploy the older version. We need to recheck and we have to redeploy during a very short time of NOD. Right? That's one of the challenges that we had. So these are some pain points that we had with the legacy application. How we transform to digitalized and how we approach the cloud native applications. I'll hand over to Linga to explain more about our digital architecture.
Thank you, Ramesh. Good morning, everyone. So here is our digital transformation high-level architecture. So we have web PCF is our choice to start build applications. Why the PCF? You guys can ask some questions to me. Basically, we evaluated a lot of platforms, but finally we ended up with the PCF because, so we have main reason is that we have a lot of SOA, like a system of like SORs on premise. So on premise, basically we have basically main reasons we have most of SORs on premises, and then customer data, and then secure the CPI and CPI data and PI data. That's a major reason where we picked the PCF. PCF has an on-premises, we can build our cloud platform. So what are our tools which we are enablers for this entire architecture, right? The tools which we have started with like CXF and then Spring Boot is our choice to build our application. So why we use the CXF framework? Because our end clients, like our retail apps or partners, we have a so tight contract, visual contracts. We don't want to change our clients. And then we wanted to use the same existing client without impacting. We use the CXF framework, Spring Boot application, and then without changing, deploy the codes. That's the one big challenge, how we need to migrate it. So that's a major one, which you picked up the CXF framework and Spring Boot using the same web services which we have earlier. Second one, Rabbit and then Kafka for the async communication between our ecosystems and then system of records. So we have challenges. Earlier, Ramesh was explaining that we have a JMSS challenges to any changes. So we use the Rabbit, MQ, and Kafka for as a loosely coupled. And the next pain point for Restrix for app resilience and then auto recovery. So whenever we have high load volumes, our backend systems, if it's down, our entire monolithic app previously stakes, and then it has a problem. So we use the Restrix pattern, so which helps for auto recovery our application. And other one which we have is Cloud Config Server, where we used to maintain our application properties in our Oracle DB, and then now we use the Cloud Config Server, which will be automatically, we can change in the on deployment, on demand, on cases, and in a timely manner. And we used a NoSQL for Mongo and a SQL for Oracle. And then we also followed 12-factor principles, 12-factor cloud principles, and then other, previously what are the RSP platform SOA principles, and then loosely coupled with our backend system, which we adapted the same. And then for the next one, which we have the independent code base point of view. Like earlier, Ramesh was pointing out that we have one big code base in one repository. So to overcome that challenge, what we did it, and then we have used the Bitbucket, where we all chunked out each single apps and put it into repository where, so that developer can pick each app and then geographically and then develop and then deploy it into development and then check into the code base. And then Maven for Spring dependency injection, and Jenkins for CI/CD pipeline, continuous delivery, application development, and deploying into containers. And then Newman is automation tool for unit testing and then integration testing. So earlier we have pinpoint, like if any change of the piece of code, we have to test entire RSP application and then regress it, and it takes a lot of time, and then more than, I think, 5,000 test cases we have to execute and all things. So here we have the unit test and integration testing using the Newman. So it will help for our development, faster speed to your production. And then we have Splunk and Splunk framework, and logging, we use the syslog. Actually, Splunk is the enabler for how to log the messages and help our DevOps team to troubleshoot any issues, and then exception rate, and then error logging, and then and troubleshooting is faster, and then fix the issues very faster to help that. And coming to our performance monitoring tools, that's called Telemetry, latest buzzword, right? The Telemetry tools, which we have it, App Dynamics, which check for the app health, and then CPU, and then memory utilization of each app, how it is running in the PCF containers platform. And it's a Grafana for error handling, and then error rate, and proactive, and then alerting to the apps team and devs team, so that they can proactively monitor and then alert and then get it, and then and proactively monitor, and then any issues are there, fix the issues. And then our other one, which we have PCF auto scale capability, so that you can the capability we used to scale up app containers instances and scale down app containers instances on demand, which we earlier pinpoint when we have more traffic, how to scale up and scale down. So we are enabling for PCF auto scaling. So these are the things we have adopted all the tools, but how we progressed, how we measured. So I'll go to the next one. So, so in 3 months, like 3 months, we have a dojo with the PCF team, and then we evaluated, and then our technical stack, tools, and all the things in 3 months, and then identified what app we need to pick it entire, because we have big monolithic and then having 400 operations, which one we have to pick. We had talk a lot and all things, which one we can chunk it up the existing big code base. And establish the pizza team, small pizza team, and then take the one app, like I call it as a usage app as a Spring Boot. So we developed, we built, and then we chunk out the code and then build the Spring Boot usage app, and then build a test automation for this app, and then validated lower environments, so which quickly, and then push this app into production with 5% traffic, enabled using service management console with the blue, green, and canary deployment without no downtime, and then zero impact to the business. Observed, monitor a couple of days, and then fix a couple of bugs, which we zero downtime and then couple of bugs with zero time, zero down. And next is after several days, monitoring moved into 25%, 50%, 100% traffic automatically. We have a service management console. We use that one to divert from the existing traffic to the new cloud app. Observe auto scaling on new load to app. Because when we started this one, when we applied, we deployed completely into the production, and then we see auto scaling is happening automatically in the PCF, and then taking the on-demand loads of the traffic, and then scaling up and scaling down when no traffic is there. So now we have low risk and drop changes as it impacts to the specific to the only app, not for entire application. Less regression test time and confidence to the nothing else will break. Our business and DevOps teams are happy. In weeks' time, we're delivering the new changes to your production. So let's measure how we started, and then we measure it over the period how we bring our monolithic application into a cloud native application. If you look at the graph, red color, it's not coming up. Okay, it's a red color, it's magenta is showing up, going up, and then blue color is coming down. So which is we started, if you look at that one, we started January. In 3 months, we all worked with our PCF guys and then make Dozo. And then we first app deployed into the March 2017. And then slowly we ramped up deployment and traffic using CI/CD pipeline, which is a Jenkins pipeline. And then we ramped up and then up to, if you see look at the middle of graph in I think in the June, July timeframe, we almost 50% went off. And then total, if you look at the total, we break up the 80 apps of 400 operation of monolithic app and running into around 150 containers, 1,500 containers, sorry. Finished this complete journey and then traffic into January 2018, from 27 to 2018. Now January, and then look at this, and then we have some performance improvement we measured. See the monolithic and versus in cloud. So green is our cloud, and then blue is our monolithic. Performance improvement is there. And look at our Death Star, T-Mobile Death Star. So it's not so big as compared to Amazon or Netflix, but this is T-Mobile Death Star. With this, I would like to ask Ravi to give some business reactions on this, our journey.
Thanks, Linga. Thanks, Ramesh. So how did this affect our business, right? So I'll go through the pain points and how we overcome those pain points. First of all, the faster response times. So if you look at the improvement that we actually made 43% improvement in the response time. So which was a huge win, which was especially for our in-house customers, it was one of the bigger needs. So we actually improved 43%. If you're looking at the numbers, on an average of 420 milliseconds, we came down to 250 milliseconds. So that was a huge jump there. Next, on the time to delivery. In the past, we used to have, as Ramesh was saying, right, we used to have one planned change and 1 or 2 unplanned changes a month. From there, we have reached to a stage where we do multiple deployments in a day. So we are able to meet the business needs on a much quicker pace compared to what we used to do in the past. So that was a huge win, and this made our business really happy. Fewer and shorter incidents. So after moving to this cloud platform, the number of incidents has drastically gone down. In the past, we used to have like close to 18 P1 incidents over a span of 1 quarter. From there, we came down to 3 incidents, which was a huge win. And also the time to resolve that issues was 67% faster. And if you're looking at the numbers there, we used to resolve 343 minutes for each P1 incident. That came down to 112 minutes. So this was a huge win for our DevOps team. Zero downtime deployments. In the past, if we had to deploy a code during the daytime, it was a dream for us. But now we can deploy a code any time of the day, especially that's helping our DevOps team avoid spending all night deploying the code. So it was a huge win for our DevOps team, and they are well rested. And to add a couple of things, right, from the cost perspective, we see there's a big improvement in the cost compared to what we had in the past. Like the total cost came down to like 1/3 of what we had in the past. So that made my leadership happy too. That's all I have. We have for the presentation. Before we go into the Q&A, I'd like to give a big shout out to Sean, who had helped us during the dojo, and also Rob, who has been consistently in touch from the Pivotal team. So huge shout out for you guys. Thank you. I'll open it for a Q&A. Sure.
You had a single monolithic application to begin with, right? With 200 operations.
400 operations.
Sorry. So you have to refactor the application to smaller apps to do the cloud migration.
Yeah, so yes, it was one single application. I have to repeat the question for everybody. So the question is like, do we have to break the big application into multiple apps to achieve it, right? So yes, we had to. That's where, because when we had this one huge monolithic app, there is a lot of interdependency in the code between these services. So it was important for us to remove the dependency from the services. So we had to actually chunk that into 80 apps, close to 60 apps. All these 400 operations fall into those apps. So yes, we had to do that. Anything else you want to add?
Yeah, so basically like in the one code base, right, the one which we have pain points, which we are testing is a more like it takes big life cycle to take into production. So chunk it out to the function based, like a customer info and then order fulfillment and those kind of chunk it out and make it as a silos based so that we use the CI/CD pipelines, can test it out and push into production easily, and then maintain the container easily and in the production side and troubleshooting and fixing and those entire life cycle of it.
You said that you have to break up the entire monolithic application into multiple smaller pieces of maybe microservices. So what was your approach? Did you do the breakup of the functionality into smaller pieces first and then deploy it on the PCF, or is it something that you did deploy the entire app on the PCF and then took chunks of it?
We actually had to break up those into chunks, make them into Spring Boot apps by its own, and then deploy into PCF.
So is there a reason for doing it this way versus the other way, where you replatform the entire app on the PCF and then take out chunks of the?
No, actually, we have the legacy app is running. We are not touched it all. That's entire stack is traffic is going into the whole structure as is. And then we took the one portion of the chunk and then put it into PCF and then route it from the service management console to 5% traffic to this particular app which we are deploying PCF container. So that way you are not disturbing your business or your end clients or partners who are traffic is going, and then it is continue as is business as usual. This one only we trial it and then each app every day because we have PCF capabilities. We deploy it and faster. If any fixes there, fix it and then deploy it back and then push if the traffic is just back it to 100% here, and then 0 is this side. And then if you have put the fix, and then come 5%, and then put the canary deployment, and then make the traffic out. So that way, those two are running all the time. We started in January, and then ended up in January. So that's how we transitioned completely.
And to answer your question, it's not like we can just lift this application and then put it in PCF and then do the migration, right? We had to do some changes, especially from the logging and monitoring perspective, right? For better monitoring for our ops team, right? So all those changes we had to do first before we deploy that into the PCF platform. Sure.
So I think following the same thing, so you took a greenfield approach on building the new services, right? So you're keeping the old stuff running the way it is and put in the new stuff.
We did not do full completely green development, but we chunked up the code. Like we don't want to touch. There is a business code.
So I get that. So what did you do during the 1 year period, because you still wanted to keep the shop running?
Yes.
Right.
How did you merge the Delta capabilities that your business is asking for?
So especially, right, what we did is like we didn't make any change in terms of the contract, right? We refactor the code itself, not the contract. So from the end perspective, there is no change. It's a seamless for them. So that is one of the reasons we didn't convert any contracts. Contract is still same, but we break down into the multiple apps. And whatever the code that requires cloud native things, right, especially the config server, histories, auto scaling, those are we refactored within the code. So that's how we approach the migration. So
And
there is
also
no
in the-
change in the contract.
Is to add to him, like during those time, like 1 year time, we are already developing, and then there is a business needs also coming in the parallel, right? We have to sync up with the parity. So we took the action on the changing there and there. So that's how we are continuing to that. We take the pain of the like 1 year. So how we need to migrate it to, so all the entire function.
Any other questions? So we'll be here around, like if anybody have more questions, we'll always be available. And if you can also reach out to us, our email addresses are there for any of your questions. We're always available. Thanks, everyone.
Thank you.